Today we are going to discuss about the Gauss law. What is Gauss law? Total electric flux passing through a closed surface due to electric field is equal to 1 upon epsilon naught times total charge enclosed by that closed surface. What is Gauss law? Remember, the total flux due to electric field for a closed surface, that closed surface we are known as Gaussian surface, is equal to 1 upon epsilon naught or 1 upon epsilon times total charge enclosed by that closed Gaussian surface. See here, Gauss theorem statement: the flux of net electric field through closed surface equals to net charge enclosed by the surface divided by epsilon naught. If vacuum is there, epsilon naught. If any medium is there, divided by epsilon. The flux, we know flux is what? E dot ds for closed surface. Total is equal to 1 upon epsilon naught times total charge. Here Q is total charge within the closed surface. See here we will use this Gauss theorem to find electric field intensity. Actually we know electric field intensity due to point charge is equal to what? 1 upon 4 pi epsilon naught Q upon R square. But there are some limitation of Coulomb's law. Coulomb's law is applicable for point charge, but if there is linear charge distribution or surface charge distribution or a body which has big size, there Coulomb's law is not applicable. So if you want to find the electric field intensity due to linear charge distribution or volumetric charge distribution or surface charge distribution, so we have to apply this Gauss theorem. So how we are applying? Firstly, describe the charge distribution, whether it is linear, whether it is surface, whether it is volumetric. Then visualize the Gaussian surface, a closed surface, identify them, take a, and what you have to do, find electric field intensity with the help of Gauss theorem. How we can find? Firstly, calculate the total charge inside the surface by distribution, and second, we are finding the flux E dot ds with the help of geometry and with the help of distribution, and symmetry also we are using. Then equate this left hand side E dot ds, integration of E dot ds with the total charge upon epsilon, and we can find the electric field intensity. So I will find the electric field intensity firstly by linear charge distribution. See here, we are going to calculate electric field intensity due to uniformly charged spherical cell or a hollow sphere. This is the hollow sphere. Here charge Q, they have given charge Q that will be distributed upon the surface of this hollow sphere. Consider a sphere of radius r. Radius of this sphere is r with its center at O, charged to a uniform charge density. This is surface charge density sigma coulomb per meter square, placed in vacuum whose permittivity is epsilon naught. So see here, how we can calculate electric field intensity at distance r from the center at a point P. This is point P. We have to find electric field intensity. I have already told, here we cannot apply Coulomb's law. We will apply Gauss theorem. With the help of Gauss theorem, we will find the electric field intensity. See here, firstly we have to think about a closed surface. What will be the closed surface? Gaussian surface. To consider a sphere. We have drawn a sphere of radius small r, taking O as a center. This point P lies on the surface of the closed sphere. What we have done? We have drawn a sphere, closed sphere, taking as radius small r. This small r is the distance between center and point, such that the center of this sphere is the center of charged spherical shell, and P point lies on the surface of the sphere. So this is the our Gaussian surface. This is the our closed surface where we are going to use the Gauss theorem. So what is Gauss theorem? You know, E dot ds is equal to what? Total electric flux passing through this closed surface is equal to total charge inside the surface divided by epsilon naught. By Gauss theorem, what happened? Total flux is equal to what? Total charge upon epsilon naught. Firstly, we are going to consider this E dot ds, total electric flux. If you see at point T, the direction of electric field will be radially outward. Here also if you will see that this is radially outward. We can see here at any point, if you will see, this will be radially outward. And what about the ds? If we will consider anywhere, this I have considered ds. ds surface, that we know the area vector, the direction of area vector is perpendicular to the surface, and magnitude is taken by the area of that element. So a perpendicular of this ds will be this. This will be the direction of ds. It can be shown by this method. If suppose I have supposed this is the spherical charge and I have drawn a sphere, Gaussian surface. Suppose this is the Gaussian surface. This is the Gaussian surface. So what will be the radius vector? This is the direction of radius vector, the direction of electric field. And if you see, what will be the direction of ds perpendicular to the surface? So this is also to E and ds at any point. If you will consider, if you are taking the lower point, this is also perpendicular. Upper point, so ds and E, by the symmetry you can see the direction of E and ds parallel to each other. As I have told you, to find electric field intensity at point P at distance r from the center of charged sphere, we have drawn a concentric spherical. This concentric spherical closed surface is Gaussian surface of radius r passing through P. This is the Gaussian surface passing through P. We have drawn hypothetically the electric field at each point on the Gaussian surface. On this Gaussian surface, electric field always they are of same magnitude and it is directed radially outward. I have shown here. All have same magnitude at any point if you are considering. So this is always radially outward, and the magnitude each and every point by the symmetry you can say it is same. And if you will see the area vector ds normal to the surface, as I have shown you by the taking spherical ball, it is also radially outward. Any point if you are taking, this is always E and ds, they are parallel to each other or they are radially outward. That's why angle between E and ds is 0. What will be the total electric flux? As you have seen, the left hand side of Gauss theorem, total electric flux E dot ds for closed Gaussian surface. If you want to consider, so what will be the E dot ds? E dot ds is equal to what? E ds cos 0. Cos 0 is 1. E is constant for every point. E we can take out. Cos 0 is 1. So E integration of ds. So what will be the total surface? Integration means total surface area. So what will be the total surface area? Total surface area of a sphere is 4 pi r square. So integration of ds for closed surface. So this will be 4 pi, radius is small r square. So what we have seen, the left hand side total flux is E into 4 pi r square. 4 pi r square. So see here, what will be the right hand side? I have finded E dot ds. Left hand side, what I have finded here, that is E into 4 pi r square. What will be the right hand side of Gauss theorem? If you see, total charge upon epsilon naught. Here total charge I have given q upon epsilon naught, or you can write q. If sigma, we have given sigma is surface charge density, so surface charge density into area of sphere. So this also q can be written as sigma into area. Area is what? Area of hollow sphere or spherical cell is 4 pi r square. So q upon epsilon naught or sigma 4 pi square upon, this will be the right hand side. So by Gauss theorem, LHS is equal to RHS, that is E into 4 pi r square is equal to sigma 4 pi r square upon epsilon naught. Also you can write q upon epsilon naught. So what will be the E? E is equal to sigma 4 pi r square epsilon naught 4 pi r square, or q upon epsilon naught 4 pi r square. So if you solve it, so E is equal to sigma upon epsilon naught r square divided by r square, or you can say 1 upon 4 pi epsilon naught q upon r square. So here you can see the electric field intensity at point P, which is small r distance from center, is equal to sigma capital R square upon epsilon r square, or 1 upon 4 pi epsilon naught q upon small r square. Here q is total charge given to hollow sphere. Here sigma is surface charge density. Here we can see कि E is directly proportional to 1 upon r square, or you can say inversely proportional to distance square, and E directly proportional to total charge given on the spherical cell. You can see this is equivalent. This is equivalent to a point charge. If point charge, if you are giving plus q charge and you are taking a point at distance r, so their electric field intensity formula is 1 upon 4 pi epsilon naught q upon r square. The same formula is here. You can see. So due to spherical charge, if point lies outside the sphere, same formula, it will behave like this spherical charge sphere or hollow sphere, spherical cell sphere, it will behave like a point charge. एक चीज ध्यान से सुनो बच्चों कि पॉइंट चार्ज के कारण जितना इलेक्ट्रिक फील्ड होगा r डिस्टेंस पर, इस स्फेरिकल चार्ज के कारण भी अगर सेंटर से हमने r डिस्टेंस पर कोई आउटर पॉइंट लिया है तो इलेक्ट्रिक फील्ड इंटेंसिटी की वैल्यू सेम होती है. तो आप ऐसा कह सकते हो कि दिस स्फेरिकल चार्ज, स्फेरिकल सेल, it behaves like a point charge for electric field intensity when point P lies outside the sphere. If point P lies outside the sphere, mean R is greater than R, small r is greater than R. I have told you E is equal to sigma R square upon epsilon naught R square, or 1 upon 4 pi epsilon naught Q upon R square. Q is total charge given to sphere. Suppose this point P lies on the sphere. If this P point lies on the sphere, so same if we'll do left hand side, right hand side. So R is equal to R, it will come E is equal to sigma R square upon epsilon naught R square, or sigma upon epsilon naught, or you can say in this form 1 upon 4 pi epsilon naught Q upon R square. This is the formula for electric field intensity when it lies on the surface. The sigma upon epsilon naught or 1 upon epsilon naught Q upon R square. Here R is capital R. Suppose if point P lies inside the hollow sphere. Here if point P lies, then what happens? If we'll see, if we have drawn this Gaussian surface, what happened? E dot ds, if we'll take E dot ds is equal to 1 upon epsilon naught total charge. Total charge inside this surface, Gaussian surface. This Q charge lying outside the surface. So inside surface there is no charge. So what happened? E 4 pi R square is equal to 0. So electric field is equal to 0. Remember this. If point P lies inside the surface, spherical shell or hollow sphere, electric field intensity will be 0. So remember, outside sphere 1 upon 4 pi epsilon naught Q upon R square, surface Q upon R square or sigma upon epsilon naught, but inside surface it is equal to E is equal to electric field intensity is equal to 0. Achha, one thing more you will remember. This formula I have given for a spherical shell or hollow sphere. If you are taking solid sphere, if you are taking solid conducting sphere, for example iron sphere, copper sphere, if you have taken, though they are conductor, and for conductor you know the charge will reside on the surface. तो आप ऐसे भी कह सकते हो कि कंडक्टिंग सरफेस के लिए, ठीक है, आयरन स्फीयर हो, सॉलिड स्फीयर कंडक्टिंग हो, कॉपर का स्फीयर हो, तो फॉर दैट सेम फार्मूला इज हियर. ठीक है, तो हम क्या कर सकते हैं बेटा, यहाँ पर अगर मैं लिख रहा हूं फॉर कंडक्टिंग स्फीयर, एक कंडक्टिंग स्फीयर के लिए भी हमारे पास वही फार्मूला रहेगा. अगर आउटसाइड यू हैव टेकन ए पॉइंट, तो आउटसाइड पॉइंट के लिए क्या होगा बेटा, E is equal to 1 upon 4 pi epsilon naught Q upon R square. On the surface के लिए क्या होगा बेटा, E upon 1 upon 4 pi epsilon naught Q upon R square. R is the radius of conducting sphere, and inside the surface, inside the conducting sphere, electric field E is equal to 0. Why? Because I have told you for the conducting surface, if you are giving the charge, it will reside on the surface. Inside there will be no charge. ध्यान देना, conducting surface के भीतर कोई charge reside नहीं करता, वो कहाँ आ जाता है, surface पे. तो conducting surface will behave like a spherical shell. हाँ, non-conducting surface is there. अगर आपका डायलेक्ट्रिक कोई मटेरियल है, उसको आप दे रहे हैं सॉलिड स्फीयर को, तो वहां पर फार्मूला क्या होगा, डिफरेंट होगा. लेकिन अगर कोई सॉलिड स्फीयर है लेकिन कंडक्टिंग है, तो कंडक्टिंग सॉलिड स्फीयर, ध्यान देना बेटा, कंडक्टिंग सॉलिड स्फीयर के लिए मैंने ये फार्मूला दिया, विच इज सेम एज द क्या, स्फेरिकल शेल और हॉलो स्फीयर. इफ यू ड्रॉ graphical representation taking from the center, this is the x distance taken from the center, and here is electric field intensity. You will see inside sphere this is x is equal to r. What happen inside sphere if you are moving? Electric field 0, 0, 0, 0. So this is 0, 0, 0, 0, 0, 0. Suddenly at r what happen? Electric field intensity becomes 1 upon 4 pi epsilon naught q upon r square. So this is the point where 1 upon 4 pi epsilon naught q upon r square. So this is the point of this. Again, if you are going away, so E inversely proportional to r square, q becomes constant. So that's why inversely proportional to graph will be like that. At infinite they will meet. So this will be the. See, this is the graph for electric field intensity. Inside 0, 0, 0, suddenly at r, this is open, this is closed. After that, inversely proportional to r square, this will be the graph of electric field intensity and distance of point from the center.